In this video, I want to go over some operations involving square roots. So the main thing I want to get across is that most operations are not scary. There will be some nuances, but they work mostly like normal operations. So let's say you want to do 2 square root of 5 plus 3 square root of 5. So first of all, what this means is literally 2 times this plus 3 times that. So if you think of it as there's 2 apples, we're adding 3 apples. All together we have 5 apples. So if you have 3 root 7 minus 8 root 7, just treat it as 3 of these minus 8 of these. There's negative 5 of these. That's it. So plus and minus work just like plus and minus with any numbers. Now if it's 3 root 7 plus 2 root 11, we can't do anything because these numbers are not the same. So you're literally adding apples and oranges. You can't do anything, so you'll be done. There's nothing to do. So these numbers inside the square roots have to be the same, or they may look different, but they have to simplify using the previous video. They have to simplify to something that looks the same. So it might be 2 root 8 plus 3 root 2, and these look different. But once you simplify the 8, it becomes 4 times 2. The 4 pops out and leaves a 2 behind. So you would get 4 root 2 plus 3 root 2, and now these are the same. So in other words, don't think that just because they don't look the same at first glance, they're not really the same. But in this case, 7 and 11 share nothing, so you can't do anything. So regular multiplication is pretty straightforward. So let's say you want to do 2 root 5 times 3 root 5. You are literally multiplying everything. So the way it works, you multiply the outsides by the outsides, the insides by the insides. So it would be 6, 2 times 3, and the insides square root of 25. Now again, remember last time, we don't actually want to even do that. The square roots just cancel each other out. Because you're squaring a square root, they're the opposites. So it would just be 6 times 5. Now in general, let's say these are unrelated numbers. Times 4 root 5. Then nothing really is going to simplify, so you have 2 times 4 is 8. Inside times inside is 15. There's nothing you can do and you're done. So multiplication, the main idea is you multiply outside by outside, inside by inside. If after doing that something simplifies, you further simplify the square root, but that's the multiplication part of it. Division works fairly straightforward. So you have 2 root 5 over 4 root 5. These are the same looking things. They cancel. This works just like usual. You get a half. So if you have square root of 3 over square root of 7, this can turn into one gigantic square root, or you can go in the other direction. For now, we'll leave it like this, but what to do with this weird thing will be the subject of the next video or two. So the only nuance here is going to be division. But in general, if the things look similar, so 10 root 7 over 5 root 7, these cancel, you get 2. If it's just 10 root 7 over 5, you just cancel these, and you get 2 root 7. So division works like it usually does. However, as I said a little bit ago, if you have something really weird like this, now these things are sort of attached to each other, so how do you divide this? For now, we have no idea, so stay tuned to the next video too, where we'll go into how to do that. So that's the only slightly tricky part. So the last part is the distributive property. So now we can apply several of these operations in one mega problem, which will set us up for later videos. This will be a good concept to get under your belts. So let's review the distributive property. So if you have this, you can do this in 2 ways. You can either add the 6 and 7 first, so you can do 5 times 13, or you can do the distributive property, which you apply the 5 to the 6 and then to the 7, and do it this way. Now, why would you want to ever do this instead of doing this? Because sometimes you don't know these values, so you want to start start visualizing it without plugging in the actual numbers. So to do this, you have to know that it's a 13, whereas here you could say, well, as soon as you give me a value, then I'll do some work. Now we can do double distribution, so maybe this itself is like 4 plus 1 instead of a 5. So now each of these will distribute to each of those, and this will distribute here and here. So we're going to have 4 times 6 plus 4 times 7. Now where am I getting the plus? The signs in between are going to depend on the signs before these numbers over here. So plus, now we're up to the 1 and 6, and now 1 and 7. And now if I had changed, let's say this were a minus, then the 4 and 6 stays the same. Now this is a 4 times a negative 7, so this would be a minus. And the 1 times the negative 7, that would be a minus. So that's how these signs are affected by this stuff. All right, so that's the basic distributive property. So how does that apply to square roots? So you can get some pretty ugly stuff where you're asked to do stuff like this. All right, so we're multiplying this quantity by that quantity. So again, the 2 is going to go here and here. This 4 root 3 is going to multiply by that and by that. All right, so the 2 times 3, so there's going to be 4 things. 1, 2, 3, 4. So 1, 2, 3, 4. All right, 6, that's 2 times 3. 2 times, we don't just think of this, we think of it with the sign. That's a negative, so we put a negative. So negative 4 root 5, because 2 times 2 is 4, and that's how basic multiplication works. Now we're doing it here. So 3 times 4 is 12, plus, so that's why that's a plus, 12 root 3. Now we go to 4 root 3 times a negative 2 root 5. So 4 times negative 2, negative 8, and this becomes 15. So that's the way it works at a basic level. Now sometimes the 3 and the 5, in this case they're not related, but what if they are related? So let's say we have 2 root 3 plus 4 root 5 times 3 root 3 minus root 5. Okay, so same thing. We're going to do 1, 2, 3, 4. So this times that gets you 6. And the square root of 3 times the square root of 3, the square root undoes itself. So that just becomes a times 3. 3 to the 1/2 power, 3 to the 1/2 power gives you a fully fledged 3. Okay, so then we go to these two. Minus, because of that, 2 root 15 from 3 times 5. Now we go to these two. So it's 12 root 15. And then we go to these two. Minus, because of that minus. Because a positive times a negative is a negative. And we have 4, and the square roots undo each other, so it's times 5. Now these can be simplified, as can these. This is 18 minus 20, so that's negative 2. Negative 2 plus 12 is positive 10 root 15. So this is an example of what happens when terms start to simplify further. So these are some common examples you might see. Of course, there'll be a ton of variations, but stay tuned. And now in the next few videos, we'll go over some intricate division steps.